Hello, welcome on Travels and Code channel. Today we will talk about Git and about two commands in Git. It's Git Merge and Git Rebase. What's the difference? How can we use them? Our plan for this lecture is we will learn what is the purpose of Git Merge and Git Rebase. We will learn how to use Git Merge and Git Rebase, and we will take a look on what is Git Rebase interactively, how we can use this operation. Also, we compare pros and cons to these operations, and I will show you how it looks in a real life world when we are using Git Merge and Git Rebase on real projects, and after that we will have some practice. We will learn how to use these commands. So let's start. Let's start from the beginning. Why do we need Git Merge and Git Rebase commands? It's a typical situation when we have master branch and we need to implement some feature. To implement this feature, we create a branch, feature branch, and we create a few commits in this branch. And after that, somebody from your team already updated master branch with its new commits. And our task, we need to incorporate these commits into our branch. How can we do it? To do it, we can use two operations. It's Git Merge and Git Rebase. Both of these commands are designed to integrate changes from one branch into another branch. So, how can we use it? Let's take a look on Git Merge. So, what do we have? We have our feature branch, we have master branch, and we can merge master branch into a feature branch using this command. First of all, we check out to feature branch, and then we merge master into our branch. As a result, we will have one new commit. It's a merge commit. I can say it's technical commit, but it creates one additional commit. And at the same time, we see the history when was created feature branch, what was the source commit, and what was changed in master upstream. Comparing with Merge, we can use Git Rebase. Git Rebase works in a bit another way. We have git checkout feature, of course we check out to this feature, and we doing command git rebase master branch. In this case, we just moving pointer from master to the feature branch, and we have this one line of history. In the same time, all commits we had before, they are new commits, and it's very important because of, I will show you one of the disadvantages of this approach. And we see that it's a one line, but we don't know what was the parent commit of our feature, but it looks better. So, and we have interactive rebase, another popular approach and very useful. To do it, we need to just add the flag E. How it works? We had 3 commits, but there are some temporal commits. For example, we fixed something or added something, and we don't need to add these commits to our main line. We can squash these commits into one and then rebase with this one commit. I will show you how it looks and how can we use it in real life. So, pros and cons of two approaches. Git Merge. Pros. It's easy to start, really, because you don't need to learn what is Git Rebase, how it works, just one command, and you are sure that you don't break anything. It's safe, because of history will be saved and you can't change anything. If you change something, you can revert these changes and go back. And the whole history is saved, because of when we are using Rebase, we are rewriting history. And it maintains the original context of the source branch. We know the last commit we used to create our new feature branch, we know context why it was created. From the cons, I can say that the history can look like spaghetti. I will show you what is it, how it looks. The next one, we need more memory, because of each commit. It saves as a file with changes, so all these commits is additional memory using. So if we can remove some commits, we can save some memory. It sounds not efficient right now, maybe for you, if you are using if you are working on small project. But if it's a huge project with hundreds of developers and you have thousands commits, it can save a lot of memory for you on the server. And one more concept is debugging with command git bisect. It's much harder because if you have a lot of additional technical commits, merge commits, and the code looks and history looks like spaghetti. So Git Rebase. What's the benefits of this approach? History looks linear, it's like one line. It's very good to understand what you are developing in your project, what was changed, and you can see the stages of growing your project, what was added, what was removed, and you can easily go from one point to another one. Then it's less memory because we don't save some technical commits, and it's very easy to manipulate a single commit because of, as I mentioned before, if we are using interactive rebase, we had 3, 4, 5 commits, technical commits, then we squash them into one commit, and if we need to remove your changes from this commit, we can just revert this commit, one commit, and we will have the previous version of our code. Cons of rebasing. First of all, it's dangerous because of you rewriting the history, and it's not a good approach. Sometimes if you do not know what are you doing, you can destroy history. The next one is more work because we need to resolve similar conflicts. I will show you why. I mentioned before, when we are creating rebase, all our commits, they are new commits, and if we have some conflicts in mainline, we need to resolve conflicts for all new commits. In case in our branch we have 10 commits and we have changes in one mainline, we will resolve all changes to all commits. It looks terrible and it takes a lot of time. And one more cons is force push. Because of you rewriting history, you need to Git prevents such operations, and you need to assure Git that you know what you are doing, and it's okay to push changed history. And in this case, you need to add the force push. So now let's go to real life example. I will show you one example of its library from Git. I found it, and let's take a look first of all on Git Rebase, how it looks. So when we have Git Rebase, the history of our project will look like this one. So we have init repository, then we see all changes we had. So we added base components, then we added style colors, we added style components, we added some variants with style components, we added colors, added jest, added build script, and all our history is saved and we see everything. It's good. I'm not sure if it was created with Git Rebase, maybe it was just one master branch, but anyway, with Git Rebase we can create this loop. So then project starts growing, and what do we have as a result? Project growing, and we have this spaghetti code when there were created new branches, and when we try to merge our new feature into master branch, we have these technical commits. It looks this one. We have master, we created feature, we added one commit to feature, and then we merged into master, and we have this one additional commit. And in this case, of course, we have our commit, then we merge into master, we have one more technical commit, and we have one more technical commit. So we see that we have a lot of additional commits, and code looks like spaghetti because we have a lot of these lines. Let's take a look. Go, we see more and more, then it was remove some of them, but it might look like this one with a big number of these branches. It's not a good idea if you have a big project and you need to maintain it. So how it looks in real life. And right now let's go to some example, and we will create a few branches and we will take a look how to use this in real life. So we have index.html file, index.txt file, it's empty repository. Okay, let's add some changes. We need git add. So in our history we see that we have new change. Let's create new branch. We create a feature branch, and we are in this feature. Now we can add some features, some commits to this branch. So let's create first change, git add and git commit. Add the comment, it will be F1, and let's create a couple of such commits. Now we see that history is changing. The same. So right now we're creating some functionality in our feature branch. So let's imagine that somebody in our team decided to implement some new functionality to master branch. And let's git now we are in master, and let's create something new. It will be changed in M1. The same git add and git commit. Let's take a look on our history, how it looks. Right now we see that we had first change, and on this commit we created a branch feature with 3 commits, and then we have master with 1 new commit. And our task is right now we need to merge our changes from master branch into feature branch, and after that, when we will update resolve all conflicts, we can merge our feature branch back into master. How can we do it? Let's do it with merge. So we need to check out feature, and what we can do, we will merge master into feature. What do we have? We have conflict, and we need to resolve this conflict somehow. So let's resolve this conflict. For example, like this one. And what do we see? We see this branch history. We had our branch with 3 commits, then we created Rebase, we merged master with m commit, and we resolve these conflicts. We have this technical commit, and now we can git check out master and git merge feature. It was merged with fast forward because we resolved everything, and we see all these commits we see in our master branch. So, and let's, for example, continue with developing in master just to see how it looks in history. So, and now we continue working in our master branch. At the same time, we see that we have history of all changes in the previous case. So, okay. Right now we can delete branch. Let's delete feature branch. Sometimes I will use the UI interface, it's easy. Okay, let's create again new feature branch. We have feature branch and we'll create a few commits. In this F1 again. For this sample right now we will use rebase instead of merge. F2 again. We need to commit them. And some new change. Okay, let's take a look on the history. Git add, git commit. Okay, we see that we have all these changes. Let's switch back to master. And we'll add some change to master. But let's do it here. M2. Let's add it and so what do we see? We see again the same approach. We have our changes in feature branch, we have commit in master, and now we want rebase. Let's do it with rebase. First of all, we need git checkout feature branch, and we need git rebase master. So what do we see? We see it was rebased successfully, and now we see that it was M1 commit for master, and we moved all our changes, changes from this M1, F1, F2, F3. It was successful. We had no conflict because of I moved this M2 in another line and it was in conflict with these changes. And now we can merge our changes back to master branch, because right now we are in feature, and when we resolve all conflicts and we are creating branch from M1, we can just with fast forward merge changes back. So git checkout master and git merge feature. So it was fast forwarded, and we see that history is saved and we are on master branch. So this is that history looks. Let's compare these two options. We see that for merge we had 3 commits plus M1, and then we have this additional technical merge commit where we resolve conflicts. But even if we don't resolve conflicts, we will have this commit. In this case we save the same how it looks. Okay, and now let's do interactive rebase. I will show you how it works. So again, we let's delete feature branch. We don't need it anymore. Okay, let's create. Let's remove everything. While we are in master branch, we will clean up our file. Okay, so again, let's check out the feature branch and we will add something. Let's add F1 again. So it's our feature F1. We want to implement feature F1, but something happened and we found out that there is a bug and we need to solve this bug because we need to add some additional functionality. It will be fixed. Let's commit this fix. So we added fix. Now we have two commits, and then we found out that there was wrong fix and we want to another fix. Let's change it to fix 2. Again, we add it and we say that fix 2. How it looks? We have our feature, but we have two additional commits. From business perspective and technical perspective, we don't need these technical commits because we need just this feature without all way how we implemented this feature. So we need to remove these commits and just leave one merge request, one branch. Okay, again, let's go to git code master. In master we again have some change M1 for example, and let's commit this change. It's M1. Let's take a look on history, and again we see the same situation. So we see that feature branch points to F1 fix 2 commit and it's a master. And now we want to interactively rebase from master and leave just one commit F1. We do not need to save this history. How we can do it? Let's go to feature again and git rebase e master. So what do we see? We see that Git opens vEditor. In this vEditor we have a final commit we can create. It suggests that we can pick previous commit. We have all commits in this branch and we can change something somehow these commits. We can let's edit it and what can we do? First of all, we have all these two fixes, two commits with fixes. We can fix up them. It means that we will squash two of these commits in one commit, and the title of this commit will be this one. But it's fix 2, so we need to fix up with the previous one. And title of commit will be F1. So all changes from these fixes will be in this commit, and as a result we have just one commit. So we need to save it. So we need escape video. Okay, the next one, what do we have? We have conflict. We have conflict in our M1 and F1. Let's resolve this conflict. Okay, we see that we have conflict with the first commit. Let's continue. again, what do we see? We see that when we are rebasing from a file where we have conflict, we see that we have again conflict with the second commit, is with the fix. We see that we added fix and we need to resolve this fix again. So let's resolve it. Okay. And again we have conflict with fix 2. We need to rebase with fix 2. We see that we have conflict again with 303 with fix 2 because of we added this fix, and we need to resolve it as well. That's why I mentioned that there's a lot of work, because of when we try to rebase, we need to resolve all conflicts for all changes, and sometimes it's a huge. And again we save, let's exit. So, and now we have final view. We rebased everything. It took a lot of time, but what do we have? We have this clean master, we fixed master, then we created M1 commit. Let's take a look at the difference. We added M1, yes, and then we have F1 commit. It's commit from our feature branch. It's just one commit. Let's take a look at the difference, and we see that it's the final commit. But when we resolve conflicts, we remove the M1, but it's not a problem. Okay, and we have our fix from all commits, and in history we have just F1. To do the final work, let's git checkout master and git merge feature branch, fast forward, and we are in master, and we have all our linear history. Looks terrific, and it's what we expected. So I showed you the difference between Git Rebase and Git Merge. How can we use them? What is the Git interactive rebase? How can solve the issue? What's the problem with interactive rebase, and in rebase in general, if we have a lot of changes, a lot of branches and conflicts in these changes, in these commits. And so you can choose what's the better case for you. From my experience, I can say that on my last projects, we always try to use Git Rebase, because if we want to save this history, it should look clean, and that's why we try to follow Git Rebase approach. But it depends on your company and your project, what do you want to use more, Git Rebase or Git Merge. So thank you for watching, subscribe to my channel, and soon there will be more interesting videos about different technologies. Good luck!